Basic associational designs. Basic associational research examines the relationship between two continuous variables leading to a correlation coefficient. There are three types of coefficient correlations used to describe the relationships between two continuous variables. 1. Pearson's product moment correlation, which is the most commonly used. 2. Spearman correlation. And 3. Kendall-Tau, both of which are only used if one or both of the variables are not normally distributed or when parametric statistics are precluded. Analyzing continuous variables with parametric statistics. Pearson's product moment correlation indicates the strength of the relationship between two variables. It assumes both the independent and dependent variable have normal distributions with equal variance for each independent variable. Pearson's correlation has a range of -1 to +1. A positive relationship, which has R values of 0.5 or greater, means that as scores of one value increase, the scores of the other value also increase. For example, individuals who participate in job coaching, job development interventions displayed both increases in confidence with regards to their ability to perform the essential job functions and an increase in daily job productivity. A negative or inverse relationship has R values below 0.5 and happens when high scores of one value are associated with low scores on another value. For example, as productivity increases for participants who received job coaching interventions, the time to complete tasks or meet quotas decreases. A no relationship or R values at or close to 0 indicates that you cannot predict the dependent variable knowing the scores on the independent variable. You can find the degree of freedom for Pearson's correlation by subtracting 2 from the number of participants. The degree of freedom is the number of values in the final calculation that are free to vary. Statistical significance and effect size. Statistical significance gives the probability that extreme results can happen assuming the null hypothesis is true. Effect size describes the strength of the relationship between the independent and dependent variables. It uses R squared to describe the amount of shared variance or variance in the independent variable. Confidence intervals and correlation matrices. Confidence intervals delineates the magnitude and the error of estimation of R and is computed using the same information needed for statistical significance, which include 1. The value of R, 2. Sample size, and 3. Fisher Z transformation table. Correlation matrix is a table of correlation coefficients showing how all variables are related to each other. They are often used because it is rare to see only a single correlation coefficient. A table displaying a correlation matrix as variables ordered horizontally across the top and vertically down the first column. Use caution with matrices because statistical significance relationships can occur without being originally hypothesized, and to interpret these is known as fishing for statistical significance. This is not good practice. Using non-parametric associational statistics. With many ordered levels in both variables, you should use a non-parametric statistic. The two statistics that are used are the Spearman rank order correlation and Kendall-Tau. The Spearman correlation is the more common of the two and provides an index of the strength of a monotonic relationship where scores are not linear. Both the Spearman correlation and Kendall-Tau are performed on ranked data rather than original scores. Misleading correlation coefficients. There are some problems when interpreting statistical significance and correlation coefficients. we should pay attention to the problems that could lead to overestimation or underestimation of the correlation coefficient. Some misleading correlation coefficient examples are 1. Restriction of range, which occurs when the range of one variable computing the coefficient correlation is limited. 2. Outliers in a small sample, which can change the relationship between variables from linear to curvular and vice versa. 3. Combining of groups, which occurs when samples from two different populations are combined. 4. When the researchers use extreme groups or participants that are selected because they represent the highest or lowest ends of a scale, excluding participants in the middle.